Okay, hello everyone. My name is Jay Klein, Director of Project Management and Staff Lead to the Digital Technology Council here at the National Institute of Building Sciences. Welcome today to Optimizing Asset Definition and Structure for Enabling Digital Twins, which is part of our Building Innovation webinar series. In this session, we delve into the critical role of well-defined asset registries and precise asset definitions in the development and implementation of digital twins. Scott Yates, Director of Digital Transformation at Wolpert, will introduce new concepts, methodologies, and standards for structuring and managing asset information to support the integration of enterprise systems. By enhancing these definitions and registries, organizations can optimize asset data usage, align with ISO 55000 principles, and ultimately improve overall asset management and asset performance. Digital twins are here and are starting to transform the built environment. However, it is important to note that the effectiveness of digital twins hinges on accurate and structured asset data. This session will explore how organizations can leverage digital twins to enhance asset management, improve decision-making, and achieve long-term sustainability goals. Before we get started, I do have a quick couple housekeeping items. First, participants will be able to type questions by selecting the Q&A button. We will select questions from this list after the presentation. Please note we may not be able to get to all of your questions, but of course, we will try our best. Second, this session will be recorded and live streamed to our Facebook page. The recording will be available next week on our website. Third, NIBS will be contacting all attendees with information regarding continuing education credits and certificates of attendance. And finally, please note that while we are providing this platform for engaging discussion to occur, it does not endorse any specific products or services. Scott, thank you for being here and taking the time to share with us today. Over to you.
Fantastic. Thank you, Jay. Let me see if I can get my screen shared here and get our presentation going. All right. Hi, my name is, excuse me. Hi, my name is Scott Yates, and I've been doing asset management consulting for over 20 years. Actually, let me pull that out of the shared screen. I'm a program director at Wolpert, focused specifically on digital transformation and asset management, which makes me incredibly passionate about data and data interoperability. I think my recent career history provides the best context as to why I'm so passionate about these topics. For the majority of my career, I led a consulting firm that did enterprise asset management system implementations across multiple industries. During this time, lack of quality data was one of the primary factors that put implementation success at risk on our projects, and data collection was always both the critical path on the project and the most expensive service line item on our implementations. Around 6 years ago, my EAM firm was acquired by an engineering firm, and this afforded me the opportunity to become more intimately familiar with planning, design, and construction projects and the technologies they leveraged, including building information modeling, BIM. It was like someone had drawn the curtain back and showed me all the data that I've been searching for 20 years. It was all right there, getting dropped on the floor or buried in project documents that would never be read by a single person post handover. It was at this moment that I was convinced that we could do better for owners, and data interoperability across the asset lifecycle has become my crusade ever since. Currently, I'm the data chair for the airport's working group for Building Smart USA, and I'm focused on helping owners develop data management and IT infrastructure strategies that will allow them to utilize AI and digital twins at scale across their enterprise. This is what I'll be talking to you about today, some specific foundational habits and instruments that I feel are required to be able to reap the benefits of these paradigm-shifting technologies. I plan to cover 3 key concepts today. First, I'm going to make the case for why digital twins rely on interoperable data. Then I'll point out some of the key ways that data interoperability is a challenge for owners, particularly in defining asset definitions and asset information structures. Finally, I'll share some techniques and solutions like asset registries, asset classification methods, and open standards that provide us a means for improving data interoperability at enterprise scale. So let's start with how digital twins rely on interoperable data. In all business industries and science disciplines, consistent and dependable decision making is centered around the acquisition of the best possible data to use as an input for determining the next best action to take. Gut feelings, instincts, and tradition might work for specific individuals or in specific instances, but is not a scalable or consistent problem solving approach. In fact, one could argue that individuals with great instincts are just people who can consciously or subconsciously assess substantial amounts of data at once and derive proper judgments based on their own knowledge and experience. Data driven decision making is the foundation for the scientific method and is at the core of any long standing successful enterprise. There was a time where data collection was onerous and assessing the data was manual. This meant that organizations had to strike a critical balance between the speed and quality of their decision making. We've always made decisions based on data, but the process was slow, labor intensive, and required focus on a limited set of variables. There can be no denying that technology has changed the speed and scale of data driven decision making. With the capabilities present today in elastic cloud computing, big data, artificial intelligence, Internet of Things, our ability to collect, process, and analyze data to make decisions has become exponentially faster and more wide reaching. This automatically means better outcomes, right? Consider the words of Joy Balamwini, the MIT student who uncovered algorithmic bias in facial recognition programs, and is a central figure in the Netflix documentary, which I highly recommend, called Coded Bias. Balamwini says if you're thinking about data and artificial intelligence, in many ways, data is destiny. It is what we are using to teach machines different kinds of patterns. If you have largely skewed data sets that are being used to train these systems, you can also have skewed results. She said this in the context of racial bias in facial recognition programs, but the exact same principle can be applied to any AI model in a business or industrial setting. Intelligence is not the default state of an AI model. AI models need to be taught how to think, and they are taught by the data they are fed. An AI algorithm literally knows nothing else of the world but the zeros and ones it is provided. In this context, you see the immense importance that is placed on data quantity and quality. As an organization digitally transforms its operations,
Scott, it looks like you might have cut out. Our apologies.
Looks like we lost Scott.
Yeah, so it looks like he's gonna hopefully sign out and sign back in. Our apologies.
I know some of you are having issues seeing the screen. Maybe this is part of it. Maybe Scott's working on a network issue.
Give Scott another moment or so. I imagine he may have had to restart his computer or something like that. Our apologies.
those of you who were having issues, I'm going to try and just share my screen, see if you can see it. Just as a test for you, see if it was on Scott's side or a network thing on your side while we wait. Maybe we'll give it another minute, and if we don't get Scott back, maybe we'll just have to reschedule. Sorry about that.
I can see yours on my end. It looks like Zoom might have done some updates where you have to double click on the screen yourself. So that could be what's happening here for some of the attendees. Yeah, we'll give Scott another minute. If he doesn't pop back on, then we'll just work to reschedule our apologies.
Okay, looks like this resolved some issues for folks, so I'm thinking maybe it was a network issue on Scott's side, so those who are having trouble, it's not you.
The excitement of live presentations.
I wonder if we have a counter, Jennifer, of days since incident. This would be
We can
0.
we can start one. Yeah, we'll have to go to 0. Let's see. So I haven't received an email from Scott either, so we might just want to just go ahead. I don't want to take up any more of anyone's time. Looks like he's probably having some serious network issues and work to reschedule this session.
Here comes Scott, I think.
Oh, is he?
Oh.
Okay. Too soon. Maybe I was ready to give up too soon.
Hello, my
Oh
goodness.
gosh. Okay, you're back.
I am so sorry. It looks like the internet in our neighborhood went out for a
Yeah.
flash, and is back. All right.
Yeah.
Let's see. Can I pick up where I left off?
Yeah.
All right.
Yes.
Let me pull this back up. Sincere apologies, everyone. Appreciate the patience of bearing with me. Let me reshare my screen.
Well, you just made it, Scott. We were about 30 seconds
You were
from
that close to
Yeah,
getting
trying to
on.
reschedule.
Hopefully everybody else stuck around as well.
Yeah.
Luckily, I noticed it pretty quickly. Sometimes I get going and talking, and then
Right.
it's like 10 minutes later before I realize it. All right, so we're seeing my screen.
Yes.
All right, fantastic. So let's jump back in. All right, so data is destiny, right? Very important. Hopefully that message came across before my internet cut out. All right, so let's talk about digital twins a little bit. So according to the Digital Twin Consortium, a digital twin is a virtual representation of real-world entities and processes synchronized at a specific frequency and fidelity. Digital twins use static, streaming, and historical data to represent the past and present, and they use artificial intelligence to simulate predicted futures. A digital twin is meant to be a fast, efficient, low-risk way to monitor, analyze, and exercise potential actions in a virtual copy of a physical system before taking any action within the actual physical system. So a fully developed digital twin should include each of the following elements: a virtual, typically spatial, model-based representation of the asset, system, process, or facility. It should have static parametric data that represents the physical characteristics of that asset or process or facility. It should also have a real-time or at least frequency-based stream of contextual, condition, and/or performance data from IoT-connected sensors installed throughout the system or facility. It should also have access to historical data about events related to the physical asset, which represents either positive or negative outcomes, and this is key, that can be correlated to the streaming data. Then there should also be the presence of analytical tools that employ some level of artificial intelligence to provide insights on how the physical asset, system, process, or facility is performing, how it will perform in the future, and the optimal response to that information. Finally, a true digital twin should have the ability to interact with software, logic controllers, actuators, motors, etc., connected by IoT to autonomously execute that proper response. Now, there's an extensive body of knowledge related to digital twins, which introduces additional terminology to break down and organize the above definitions that I gave to an even more detailed level. However, these will suffice for this presentation's purpose. The most important concept to understand related to the definition of a digital twin is that it is created directly to influence business outcomes. Specifically, they exist to improve efficiency and resiliency.
I am so sorry to interrupt you, but it looks like a lot of people are having issues seeing your content. I'm wondering if you could
Sharing
stop
again.
sharing and then maybe start sharing again. They were able to see Jay's screen when he did it. I'm so sorry. This is like,
No, I apologize. It was my
oh no.
hiccup that got us into this situation. So let's see if I can reshare.
We've brought back the excitement of in-person
Right.
issues to the web.
Let me close out of there. And let's go back to share. And represent. How are we looking?
So I can see it, but I also could see it last time. I'm hoping maybe someone can come through with a message here. I'm so sorry.
That's all right.
It seems like still half and half.
Yes, yeah. So there might be some
One
setting
confusing thing.
issues on Zoom. Well, Scott, if you can definitely share your presentation, we'll make sure everyone gets a copy if that's okay.
I absolutely will, and
Okay.
hopefully the recording is picking up
Yes, yes, the recording is working and it is
with the
unfortunately going to
shared
have
screen.
all of this too, but we will have it recorded and of course we'll send out the link and we'll send out your PDF and all of that. So our apologies for those who can't see.
Yeah, no, sincere apologies. I'm happy
Mm.
to share this. You can also reach out to me directly on LinkedIn, or my email will be at the end. I'm happy to share the information that way as well. So,
Okay. Thank you, Scott.
all right, we're gonna give it so third time's a charm. Let's see how the rest of this pans out. Let's see what else can go wrong. But just wrapping up kind of the intro to digital twins. So, again, it's about the use cases that they support. And so as such, I think we're better served by looking at digital twins as a program or an approach to business operations versus a standalone, discrete information technology platform or software implementation. At the end of the day, it is the ultimate exercise in systems and data integration. So that being said, there are two critical concepts that influence how we manage and leverage data in the asset management and digital twin landscapes: technical integration and semantic integration. First, let's define what we mean by these terms. So, technical integration is all about the mechanics of how data physically flows between systems. It's the nuts and bolts of the data exchange, how systems talk to each other, how data is transferred, stored, and accessed. This is the foundation of any data interoperability effort. If you want systems to work together, technical integration is non-negotiable. But just having data moving between systems isn't enough. This brings us to semantic integration, which is where things get a little bit more nuanced. Semantic integration is how data is understood and interpreted by different systems. It's not just about moving data from one place to another, it's about making sure that the data retains its meaning, its context, when it gets to its destination. Without semantic integration, even the most sophisticated AI models will struggle to make sense of the data they're given. Now, why is this distinction so important? Well, as we move further into the age of digital transformation, especially with technologies like artificial intelligence and digital twins, the ability to integrate data across multiple systems becomes a competitive advantage. The truth is, the quality of the data you use and how that data is understood by all systems will directly impact the effectiveness of artificial intelligence models and ultimately your decision making. So think of it this way: technical integration ensures that your data gets to where it needs to be, but it's semantic integration that ensures your data makes sense once it arrives. If we want our AI systems to be truly intelligent and capable of driving strategic decisions, we need to ensure that data is both properly exchanged and properly understood. I often compare this to the concept of the golden thread of data in asset management, which represents the continuous and unbroken chain of data from the conception of an asset through its design, construction, operation, and eventual decommissioning. This data chain needs to be both physically and semantically integrated to ensure smooth transitions between each phase of the asset lifecycle. If we drop the ball on one of these, the result is often a frayed data thread, leading to inefficiencies, errors, and higher costs. Ultimately, ensuring both technical and semantic integration isn't just a technical challenge, it's a strategic business decision. It's about creating a foundation that allows for better decision making and more effective AI applications. It's about investing in data now so that your systems can perform more efficiently for years to come. All right, let's talk about data quality for a second before we go too much further. Quality is one of those ambiguous terms that requires some upfront definition to be effective as you're delivering a message or a presentation. I've recently coined a phrase, the 5 A's of data quality. Well, I actually coined the phrase, the 4 A's of data quality, but I've added a fifth A recently, the more I've been working with artificial intelligence and trying to solve specific problems. The new one is alignment, but we'll get to that one in a minute. At the core of any data-driven strategy are these 5 critical qualities: abundance, accuracy, accessibility, alignment, and ASAP. Okay, the last one's a little bit of a reach to keep with the A theme, but it's meant to represent the concept of timely data. And together they form the pillars that support the success of any digital transformation, particularly as we integrate complex technologies like digital twins and AI. Let's break each of these down and see how they enable smarter decision making, faster actions, and ultimately more efficient business processes. First, abundance. This one's pretty straightforward. Having a wealth of data is the first step. This means both more records within individual data sets, but also more types of data sets as well. We need data that spans all phases of the asset lifecycle, from design and construction all the way through to operation and maintenance. The more comprehensive our data, the better equipped we are to make informed decisions. Think of it like a toolkit. The more tools you have, the more problems you can solve. Next up is accuracy. Accurate data is the cornerstone of everything else. If your data isn't right, nothing else matters. Inaccurate data leads to poor decision making, which leads to inefficiencies, risks, and wasted resources. It's like trying to navigate with the wrong map. It doesn't matter how fast you go if you're headed in the wrong direction. Accuracy ensures that every decision you make is grounded in reality. Moving on to accessibility. It's one thing to have data, and another to be able to easily access it when you need it. Accessibility is what turns raw data into actionable insight. If your data isn't easily accessible, it's like having a great library but not being able to find the one book that you need. In the age of digital twins and real-time decision-making, accessibility is essential. Now, alignment, the one I've added recently. This one is also key. And this refers to how well your data sets match the objective you're trying to achieve. Every specific problem requires specific types of data to arrive at an appropriate solution. If your data is misaligned, or if it's too broad as it's being applied to your problem, your prompt, it creates an unnecessary noise that can obscure the real issue. Without proper alignment, it's like trying to solve a puzzle with pieces that don't fit. Data that isn't tailored to your objectives will only complicate things and make it harder to find the right answers. Finally, ASAP, or timeliness. In today's fast-paced world, data that isn't timely is practically useless. The right data at the right time allows you to make decisions quickly and confidently. This is particularly true in asset management, where issues like maintenance and operational efficiency or response demand quick action. The faster you can act on accurate, accessible, and aligned data, the more you can minimize risks and reduce costs. Together, these 5 A's are the backbone of data interoperability. They're what allow us to transform data from an investment into a powerful asset unto itself that drives real-time informed decisions. By focusing on these elements, we can make sure that our digital transformation isn't just about adopting new technology, but also about empowering our teams to make smarter, faster decisions. All right, so let's dive into some of the challenges we face as it relates to asset data quality, as data interoperability is a difficult thing for most organizations that I've worked with to achieve, particularly in relation to asset management. I'd like to start with a parable. There's a relatively well-known parable, the 6 blind men and the elephant. In this story, 6 blind men are asked to touch an elephant and describe it. Each man feels a different part of the animal. One touches the trunk, says the elephant is like a thick snake. Another touches the leg and insists it's like a tree trunk. The third touches the ear and thinks it's like a fan, and so on. Each of these men is describing the elephant from his limited perspective, and as a result, each has a partial, incomplete view of what the elephant truly is. None of them is wrong, but none of them is right either. The problem isn't with the men, it's with the fact that they're all looking at a piece of the whole without seeing how their individual experiences fit together. This is a perfect analogy for the challenge we face when defining assets across an organization. Different stakeholders, whether they're in operations, maintenance, engineering, or finance, will each define and interact with assets based on their unique perspective and needs. For example, an asset manager might define an asset in terms of its lifecycle cost, while a maintenance planner may focus on its functionality and downtime and reliability. An engineer might define it in terms of technical specifications. And finance will be concerned with its capital value. Unfortunately, ISO 55000 doesn't directly solve this challenge for us either. The very definition of an asset, according to it, is an item, thing, or entity that has potential or actual value to an organization. Well, there's a couple loaded terms in that definition. First off, the definition states that it is unique to a particular organization. So it requires organizational context and is therefore not universal, even across a particular industry. Second, the term value can be incredibly problematic as well when trying to define standards. What's valuable to me may not be valuable to you. So again, we have a portion of the definition of an asset that requires a specific perspective to have any meaning at all. So when we work on universal asset definitions within an organization, just like the blind men, each stakeholder is working with a piece of the puzzle. And while their definitions aren't wrong, they don't give us the full picture. Without alignment between these underlying individual definitions, you end up with fragmented data, confusion, missed opportunities to optimize asset management across the organization. Another way to look at this same problem is from the perspective of our information systems, which mirror the varied perceptions of our stakeholders. Our GIS systems are most concerned with where our assets are. Our BIM systems, they're also concerned with where assets are, but they're particularly concerned with what that asset does and what it's connected to. Our financial systems, our ERP systems, care about how much it costs. And our enterprise asset management systems and CMMS systems care about its current status and the reliability of specific components, and on around to the other enterprise systems we have for managing asset-related information. These system lenses drive even further variation in how we define and depict, how we define and depict assets in our information systems. While the GIS system may function adequately to solve user problems by knowing where the air handling unit as a full assembled unit is, the enterprise asset management system requires the breaking down of it into subassembly components in order to support reliability-based maintenance programs, which may drive different maintenance frequencies for different components of that same asset. Just to make it more fun, your financial systems may not even care about the discrete assemblies. They may only be concerned with the current book value of the aggregated system or facility it was installed for. But wait, there's more. Our IoT systems, BMS, SCADA, etc., often don't even see them as assets, but rather a collection of measure points. This is the landscape we are in while trying to define universal asset definitions and data schemas. I wish luck to you all in trying to do that. We can see why it's so hard to enable data interoperability in asset management. But let's think for a moment about where the most significant break in the golden thread occurs in the asset lifecycle, at handover, in between construction and operation. How familiar does this diagram look to all of you? At project handover, the owner is, hopefully, provided with a dump of countless volumes and versions of models, drawings, product submittals, O&M manuals, etc., etc. If they're lucky, this information is organized in a manner that is at least intuitive to the people who are on the project, but nonetheless cryptic to every other stakeholder in the owner organization. So what happens with this mess? Well, for the stakeholders that are motivated enough, they'll dive into that murky darkness and pull out the specific items that they can find that they think they need, and then we'll go through a process of reformatting, relabeling, and reclassifying, all of that information to fit into their specific information system. And we wonder why building effective system integrations for performing cross-system analysis is so difficult and expensive. We've gone and frayed that golden thread to look like a tangled mess, never to be interwoven again. To truly get a complete understanding of our assets, we need to make sure that all these different perspectives are integrated. We need a common definition that's flexible enough to meet the needs of all the stakeholders, but structured enough to provide consistency across the organization. Only then can we ensure that we're managing our assets effectively throughout their entire life cycle. Okay, so hopefully I've proven that it's difficult, although I'm sure many of you already know that this is a difficult problem. But what are some of the things we can do to overcome these challenges and improve the interoperability of our asset data? Before an organization can even begin to attempt to build enterprise-scale digital twins, it is imperative that they establish a framework for defining and organizing assets across all of their business processes and enterprise systems. This framework should provide the backbone to specific data standards for digital asset delivery on capital projects and should encompass the requirements of all of their asset information related systems like EAM, CMMS, ERP, GIS, and more. As they move forward with any digital transformation efforts, this framework will provide the primary data schema for a connected data environment that serves as an asset registry for all enterprise applications. The definition and structure defined during this process will guide what is to be defined and captured as an asset during projects, as well as how to structure the associated data being collected. You should not be looking to create universal asset definitions across all stakeholder groups. One size fits all does not work. And you should not be looking to re-engineer how individual stakeholder groups structured their data for their purposes. What you're actually looking to do is create the decoder ring that can be referenced to relate the data across these various systems. A method we've developed for helping to define the structure of this decoder ring within an organization is called the lowest common classification methodology, or LCC. LCC defines a common starting point for each asset type, for asset data across all your enterprise systems. Any asset record in any individual asset information system would be required to relate its records back to this particular level of the asset framework for that particular asset type. For example, let's assume an owner has decided to utilize Uniformat as the backbone to their classification system. They may determine that air handling units are an asset tied to the service of distributing air to a portion of the facility. And as such, they decide that this is what they want their LCC to be for this type of asset. This would mean each air handling unit will be captured as a discrete asset, but no individual information system is required to break it down any further than that unless they have a reason to do so. So this has two major implications for downstream systems like your financial system or your EAM system. The first is that an individual air handling unit could be broken down into more granular components that are defined as assets in your EAM. So you could break out the supply fan, dampers, blowers, etc., in order to create maintenance programs for each. But that system is not required to do so by the standard. So you can do it if you want to, but you're not obligated to go beyond the LCC. The second implication of this is that if the asset is broken down into more granular detail in the enterprise asset management system, as an example, then that system must also store the relationship back to the LCC level, meaning there must either be an attribute or a stored relationship that associates the tracked components to the specific air handling unit they're associated with. Now, this methodology works in reverse as well. Using the same example as above, the financial system, the ERP system, might aggregate multiple air handling units and other assets into a larger air distribution system for a facility or a project, a renovation project, to track its depreciation. Still, if it does so, an attribute or relationship must be established to map back to the individual LCC assets that make up that particular system or that particular project. Now, to determine the LCC, an organization must understand its organizational goals, asset management objectives, and service level requirements for its assets. The level selected for the LCC should align with the definition of services and service levels associated with the asset. This is what's going to be most effective. So, for example, a facility has moving walkways to serve the function of moving people from one point to another. The moving walkway is what provides the function, not the individual components. While a motor may allow the moving walkway to operate, the motor itself cannot move people. So one way to work through these definitions is to create a boundary diagram. The figure on this slide gives an example of a potential LCC definition that defines a domestic water pump as the LCC. Utilizing the example on the slide, the organization will have established that the domestic water pump at the organization's defined level 5 of uniformat, in this case, is the minimum level of granularity all asset information systems must relate to, regardless of whether the system manages the components at an even lower level or aggregates this asset to a larger entity like a system, facility, or project. So again, using the example of the enterprise asset management system, can have the transmission, the pump controller, the lubrication system as individual assets, so long as it also has the relationship to the specific domestic water pump assembly that they're a part of. Conversely, the financial system might aggregate all the water pumps and other water distribution system components installed as a part of a discrete project and track the book value of that as a system as a whole. In this method, it's okay as long as the system maintains a relationship to all of the individual LCC assets that it's comprised of. Is defining this type of framework using the LCC method tedious? Yes, but it's necessary. And the bulk of the effort can be done once, utilized on every project and across any system integration, and then revisited periodically to address new scenarios like new technologies. It should also make you feel better that while these types of standards placed in the hands of humans often result in spotty adherence, a trained artificial intelligence model is going to use it consistently every single time if instructed to do so. So what that means is the return on investment for data standards and standard operating procedures is actually increasing significantly in the age of AI because they actually get implemented and followed consistently. Now, another key recommendation for addressing both semantic and technical integration problems is the establishment of an asset registry. The asset registry becomes the living embodiment of your data interoperability standards, the physical manifestation of the decoder ring that we discussed. An asset registry is a centralized, structured database that stores a central listing of all of an organization's assets, providing a single source of truth for tracking, managing, optimizing their lifecycle. The asset registry can be a new standalone system built for this purpose, or it can be housed in one of your already present asset information systems like your EAM or your GIS. Your unique organizational objectives, processes, and IT infrastructure are going to guide you to the right answer to that question. But the bottom line is that its existence is critical. Also, the asset registry does not need to replicate the primary functionalities of any of those other enterprise systems that I mentioned. You have each of those systems for a reason. They are good at what they do. The asset registry is simply meant to provide the basic identification information and relationships to trace each asset to its related objects in other enterprise systems. It's just an index. With an asset registry established and integrated early with your planning and design processes, we have a fighting chance protecting the golden thread, particularly at that pesky point of handover. So let's revisit that handover slide again, but let's do so this time with the presence of an asset registry. With an asset registry in place, we begin to capture, identify, and index assets early in the life cycle of a project, and we establish the routes that we can begin to tie to other enterprise systems, even before a project is complete and handed over. This gives us the added benefit of being able to use that information and the power of those enterprise systems in operational readiness planning, long before the physical facility, system, or asset is handed over. Something that most organizations rely entirely on tribal knowledge and manual facilitation to do, if they do it at all. Finally, with assets identified earlier and enriched throughout the process, project handover becomes a true non-event, at least virtually speaking. And we're in the position to optimally operate, maintain, and track our assets from day one of their existence. We have successfully protected the golden thread across its most perilous point, and we have established the foundational strength to keep processes, systems, and data integrated through the remaining life of the asset. Now, I'd be remiss, particularly in front of this audience and as an active member of Building Smart, if I didn't mention the importance of open standards on any organization's data interoperability efforts. Open standards are publicly available specifications that provide a common framework for designing and implementing interoperable systems. First off, open standards are built on principles of transparency, collaboration, and consensus. Transparency ensures that everyone can see how the standard is being developed, um, making the process open to scrutiny and feedback. This collaboration leads to more robust, comprehensive standards that reflect the needs and expertise of diverse stakeholders. And most importantly, open standards are consensus-driven, meaning they represent the collective agreement of various experts and organizations, ensuring broad support and applicability. Then we move on to the use. Open standards are not just about being available, they need to be freely adopted, implemented, and extended. This means that anyone can adopt the standard without restriction, ensuring that solution remains flexible and evolve over time. They also need to be easily implemented, which allows organizations to integrate them without facing steep barriers or excessive costs. Lastly, they should be freely extended. As technology and needs evolve, open standards should be adaptable, enabling innovation without being bogged down by rigid implementation or limitations. In practice, open standards allow for better data interoperability. They provide a common ground for different systems to understand and process data in the same way. This not only reduces complexity, but also improves the efficiency of decision-making, driving faster and more reliable results. What are some of the benefits of open standards? Why are they so essential, particularly when it comes to achieving true interoperability and unlocking the potential of digital transformation and asset management? At the top of the list is everything we've talked about today already. It's interoperability. Open standards are the foundation for enabling systems and technologies to seamlessly communicate with each other. Without a universal framework for data exchange, different systems, whether it's your asset management platform, BIM software, maintenance tools, can't talk to each other effectively. Open standards remove this friction, allowing data to flow freely across platforms and ensuring that every system in your infrastructure can operate cohesively. This is absolutely crucial when we're talking about integrated systems like digital twins. We need to ensure that the data across all platforms is not only connected, but also meaningful and actionable. Next, we have innovation. Open standards encourage innovation because they offer flexibility. Unlike proprietary standards, which often lock you into one vendor or solution, open standards provide the freedom to explore new technologies, systems, and tools as they emerge. This means you're not constrained by a single vendor's ecosystem. You can adopt the best solutions for your needs. Open standards facilitate collaboration between vendors, enabling you to mix and match technologies that best suit your goals without being restricted by compatibility issues. That brings us to reduced vendor lock-in. This is a major advantage of open standards. In many industries, organizations find themselves stuck with a particular vendor because of proprietary systems and technologies that don't integrate well with anything else. With open standards, you're not tied down to any one solution. You can switch vendors, upgrade your systems, or integrate new tools without worrying about losing compatibility or functionality. This freedom allows you to make strategic decisions based on performance, cost effectiveness, and the latest innovations, rather than being forced into a particular vendor's offering. Lastly, collaboration is a huge benefit. Open standards are consensus-driven, meaning they are created with input from multiple stakeholders, vendors, users, and industry experts. This collaborative process ensures that the standards meet the needs of everyone involved, from the small contractor to the large enterprise. It fosters an environment where solutions are not only effective, but also aligned with the collective needs of the industry. It's about creating a shared vision for progress, which ultimately benefits everyone. So open standards unlock interoperability, fuel innovation, reduce the burden of vendor lock-in, and encourage greater collaboration. They are the backbone of modern infrastructure and asset management systems, driving flexibility and efficiency in everything we do. On this slide, I just wanted to point you towards some of the open standards that exist out there for asset data. I want to be clear that this is not everything that is out there. And there is actually some very recent discussion in this space as to what the next generation of standards need to look like to fully leverage the richness of all of the types of asset data that is out there, which is getting crazier and crazier every day. In particular, I would pay attention to the discussions around interoperable building blocks, IBB, where open standard legends Linux are jumping in to work on interoperability of our IoT data. I would also pay attention to the discussions around making our standards more object versus file based. And finally, the discussions around aligning with universal scene description as a standard for 3D rendering. These are all hot topics happening in the industry right now to ensure that we continue to have open standards that meet all of our asset management needs. Now, for the ones I'm presenting here, for obvious pragmatic reasons, most open standards are geared more towards technical integration than semantic integration. So we have industry foundation classifications. This gives us the ability to exchange asset information, including geometry, out of BIM models. We have the information delivery standard, IDS. This gives us the ability to exchange owner data requirements for IFC-based deliverables in both, and this comes in both human and machine readable format. And so in this way, it addresses one of the major sticking points in getting quality data on design and construction projects. And that's truly understanding what the owner is asking for and being able to validate that it's there in the project deliverables. We have the Building Smart Data Dictionary, BSDD, and this provides an extensible reference for standard terms and attributes organized by common asset types. We have the BIM collaboration format, BCF. This allows us to exchange issues and comments related to BIM models. And then finally, here on this slide, we have Construction Operations Building Information Exchange. This is better known as COBE, but this allows us to replace paper construction submittals for asset data, enabling more robust migration and integration processes to your downstream systems. And all of these give you the ability to do these things across software platforms. That's the key, regardless of what you or your contractors use. All right. As we come to the end of today's session, we made it through several hiccups. I want to leave you with a few key takeaways. First, let's remember that digital twins thrive on interoperable data. Without seamless data exchange between systems, the full potential of digital twins will remain unrealized. Unfortunately, for most organizations, their data simply isn't that. It isn't interoperable yet. This is where asset registries, the LCC methodology, and open standards come into play. Asset registries serve as the backbone, enabling us to index and track every asset across its lifecycle, ensuring consistent identification and relationships across our other systems. But then also, by adopting the lowest common classification approach, we create a common starting point that aligns data structures across these various enterprise systems, making data more consistent and easier to interpret, no matter what software platform you're using for what purpose. But it doesn't stop there. Open standards are critical for ensuring that your systems can communicate effectively. They provide a common framework for data exchange, allowing data to flow freely across systems, reducing vendor lock-in and fostering collaboration. This in turn fuels innovation and helps you stay agile, ensuring that your technology stack can evolve as new solutions emerge. When we combine these elements, asset registries, the LCC method, open standards, we create the interoperability needed to support scalable, future-ready digital asset management systems, including digital twins. But most importantly, we start to untangle the complexities of our data ecosystems, moving us closer to the streamlined, efficient operations that digital twins and AI-driven decision-making promise. So as you move forward in your own digital transformation journeys, remember that the foundation for success lies in creating a solid data framework. It's about ensuring that your asset information is not only available, but is also accurate, aligned, and timely. With the right infrastructure and standards in place, you'll be well equipped to reap the full benefits of these transformative technologies. I want to thank you for your time today and making it through the hiccups. Hopefully some of you made it to the end. And as we collectively look to make asset data interoperability a reality, I ask you to consider the words of my adopted life coach, Ted Lasso. There are two buttons I never like to hit. That's the panic and snooze. All right. With that, I think we have a few minutes here, not quite as many as I originally anticipated, and we can certainly take any questions that we have from the audience.
Looks like we don't have any questions coming in. Maybe I'll throw one out there for you, Scott, that was on my mind while we wait for folks to
Appreciate it, Jay.
type into the chat. I was wondering, you showed your asset registry. I was curious about, do you think it's important in that registry to identify sort of like the source um, of your primary asset where it would be editable and not editable?
100%. The way I see the asset registry is as the physical and actionable embodiment of your data management and governance standards. So, first and foremost is being aligned on a master asset list to be able to start to create that decoder ring. But then you build out from there. This is where you're storing all the information that lies in the interstitial space between the systems. So any sort of information you can provide around the source, the destinations, which could be multiple destinations, where this stuff can be edited, what it looks like in those other systems. So that's where we would have the translation of in the financial system, this is actually part of a larger system, or in the EAM, this is broken down into smaller components. But it's meant to represent the interplay of data in between your various enterprise systems. And so where I would start is by defining an enterprise asset data management plan, which includes your governance and the connection between these systems. And then you look to build a database that allows you to actually enforce that and create transparency behind what's in that document.
Right. Great. Thank you. We do have a question now from Silvana. Is government consuming this type of asset management at the high level technical approach as you presented?
And so our government agencies doing this, I think, is the question. Yeah, absolutely. And without name dropping here, I'm actually working with several federal, state, and local government agencies to put this type of strategy in place. This is a foundational element to being able to do true asset lifecycle management and being able to ultimately support things like digital twins and artificial intelligence. So absolutely, there are many government agencies that are starting to tackle this type of strategy and have already adopted certain pieces. So as an example, open standards are already very prevalent across federal departments. But yeah, there's absolutely specific efforts underway in a lot of places across the government. And this is one of those things. Again, if you reach out to me offline, I'm happy to discuss more details related to that.
Great. Thank you. Let's see. Daniela asked, what is the relationship between optimizing and enabling a digital twin and technical debt? What do trends show? Do you see technical debt decreasing over time as digital twins mature?
Yeah, I 100% see technical debt decreasing over time as digital twins mature. Digital twins, the way I like to talk about them is you really need to look at them in an organization as a program, not as a platform or a software solution. The concept behind digital twins is that we are getting better at aggregating and organizing the underlying data that our organization depends on. And then we're tapping into the value and the capability of artificial intelligence in order to make do analysis across that data set, make observations, forecast future. And so this is something that is going to continue to evolve over a long period of time, but it's completely changing the paradigm. And really, AI is at the heart of this. I mean, digital twin is just one particular manifestation of AI, but AI is what is at the heart of this, of being a complete paradigm shift for organizations in how we interact with technology. I believe we're starting to move away from the enterprise application age and move towards an age where we are curators of standardized data. We have hopefully at an organization level, a standardized user interface with how we interact with technology. I think it's going to be, chat-based agents. And then in between, you have a myriad of AI-based models, algorithms, agents that are optimized to perform specific activities. And if we do this right, it should be relatively transparent to the end user. You are going to work with your AI teammate to identify and solve problems in your organization, and they're going to tap into all these capabilities to do that. But yeah, it's an evolution, but that's why starting with these foundations are so critical. How far you go in that program, in that evolution, is going to be largely dependent on how good you are at curating and managing your underlying data sets.
It's good. Thanks, Scott. I think we're about out of time. We got 1 minute here to wrap up. I think you already said your final words, but I want to give you a chance. If
Yeah,
there's
no,
a
sure.
question we haven't asked that we should ask,
No, I would just say,
what would that be?
listen, I know we probably have a mix of both, architects, engineers, as well as owners on this call. I would just leave you with this. If you are an owner and you do not have a data strategy around asset information and how you're going to support these types of technologies moving forward, I highly recommend that you start looking into that. If you are an architect or an engineer, I think it's important to stay on top of these types of topics because it gives you a peek into why owners are asking for the things that they're asking for, the value that they derive from the data as much as the physical facility that you're providing to them. And, I think that's something that we're seeing change very rapidly, where the actual virtual deliverables are every bit as important on a capital project now as the physical facility itself, because they're directly intertwined with how that owner is going to be able to optimize operating and managing that facility for its life, which could be 30, 40, 50, 60 years. Right. So those are my final concepts there as to what hopefully you get out of this particular presentation. Again, please feel free to reach out to me any questions on these topics or related topics.
Great. I captured everyone's questions that we were not able to get to. I'll share those with Scott. Um, and thank you all for your time. If you are still here, NIBS, if you're in the DC area, has our annual conference next week. We have 25 sessions, 65 speakers. The bulk of the day is on the 20th, with a welcome reception the night before and a few sessions in the morning on the 21st. So if you're looking to join an event, continue conversations like these, there'll be quite a few conversations had there. In addition to that, you can stay involved through the Digital Technology Council at NIBS as another way to plug in and get more exposure to Scott and others through that group. So thank you all for your time. Excellent presentation, Scott. Very valuable, I think, to all of us. Appreciate it very much. Take care.